Let us see some problem based on van der Waals equations. So this is the question. For a real gas, molecular mass is 60, density at critical point is 0.8 gram per centimeter cube, and critical temperature is 4 into 10 power 5 divided by 821 Kelvin. Then what is the van der Waals constant A and in atmospheric liter square per mole square? So here we have given molecular mass of the gas 60 and density is 0.8 gram per centimeter cubes, and we have to find A value. Temperature is given. So one thing we know that a critical temperature is equal to 8A by 27 R into B. So critical temperature is equal to B, we have to find out. So B we can find out if we know the critical volume, that we know that Vc is equal to 3 into B. Okay, so we need to find out V. So how to find Vc? So Vc, for finding Vc, molar mass of the gas that is given at critical point, density also given. So we will divide 60 by, this is your so 0.8 gram per centimeter. So if you divide by 0.8, so we'll get here value. So some value will get here. So again, so we got the value of Vc. So again, what will be the value of B? So here B will be Vc upon 3. So Vc we know that. So if you divide it, so you will get here, this is 30, this is your 0.4, this is 0.2, and this is 15. These are 15. So again if you divide it, it will become here 150 by 2, that is 75. So here 75 by 3. So we know the V value. Now we can put directly this value over here. So Tc we know that this Tc is given here 4 into 10 to the power minus 5 10 to the power 5 by 821. So we can write here 4 into 10 to the power 5 divided by 821 equal to 8. A we don't know. So 27. R is how much? R is gas concentration. This is given in atmospheric pressure. So 0.0821 and multiplied by, so here B is given here. So we solve it. So this we will get here 25. So this is centimeter cube, this is centimeter cube. So it you must convert into liter cube. So again you have to multiply by 25 into 10 power 6. So we'll get here 0.025 liter per mole. So this is 0.5 liter. So here you put, because this is all are in SI units, so here you multiply 0.025 liter per mole. Okay, so this is the whole equation. So on solving, so we'll get here value of A is equal to 3.375. So this is the answer. Van der Waals constant, next problem. The van der Waals constant B of a gas is 4 pi into 10 power minus 4 liter per mole. How near can the center of two molecules approach each other? So how near means they will be approaching very close to each other. So this is the two molecules and these are the center of these two molecules. So we have to find, this is the only nearest center. So this is the R, this is the R, okay, and this is the 2R. So we need to find the distance between the two molecules. So B is given here. So again we know that B is equal to, we know this formula, 4 into 4B is there. So 4B into Avogadro number. Okay, and 4B is this is the volume of one molecule. B is the volume of one molecule. So this is the formula. We know the van der Waals constant. So 4 given here, volume of one molecule is 4 by 3 pi r cube, and this is the Avogadro number. So Avogadro number we know that that is 6.023 into 10 power 23. Okay, so again B value they have given over here, 4 pi into 10 power minus 4 L per mole, and again this we know from the van der Waals constant. So B is this value, so we can compare this and this value. So this implies that 4 pi into 10 to the power minus 4 liter per mole, which will be, so this is a liter per mole. So we can multiply by, if you are writing gram, so you can multiply by so per liter means this is your 1000, then this will be your 4 into 4 by 3, and this is your pi into r cube into 6 point, so we neglect 0.03 value into 10 power 23. So on solving this one, so this is we'll get here how much. So this is your value, solving r is equal to, or solving this becomes 4 pi. If you cancel it, this one, all you cancel it, so we this is also 1. So on getting here value 5 into 10 to the power minus 9 centimeter. Okay, and distance of closest approach. So closest approach is nothing but it is 2r. So this will be your 2 into 5 into 10 power minus 9 centimeter. So this we will get here 10 to minus 8 centimeter, or we can say minus 10 meter, that is 1 angstrom. So this is the answer. The density of a vapor of a substance X at 1 atmospheric pressure and 500 Kelvin is 0.8 kilogram per meter cube. The vapor diffuses through a small hole at a rate of 4 by 5 times slower than oxygen under the same condition. What is the compressibility Z of the vapor? So here we need to find the Z. So Z, we know that Z is equal to P Vm by RT. So this is the Z is given here. So we know that Z we have to find out. So again, if you see here, pressure is given, R is given, T is Vm we don't know. To find the Vm, so we have to take the value of this one, rate. So this is a slow is there, slower than the oxygen. So we have to compare this vapor with respect to oxygen. So this is the question comes under Graham's law of diffusion. So rate of the X gas by rate of the oxygen. So as we know, this formula is there. So molecular mass of the X and molecular mass of the oxygen. If you solve it, rate they have given 4 by times 5 times is lower. So this is 4 by 5 whole square. And again, if you solve it, so this is the square root of 32 molecular mass of the oxygen 32 and molecular mass of the X is there. So again, if you solve it, on solving this will be your 16 by 25. So here molecular mass X will be 25 into 2, this is 50. Okay, so we know the now one more thing, density of X is given, molecular mass we know that density X is that density of that vapor is 0.8 kilogram per meter cube. So this means what? If you take 800 gram in 1000 liter or 1 meter cube. So we know the volume. So volume of molar volume will be 1000 is the mass, okay, and 800 is the gram, okay, 800 gram. So this is given here. So the molar volume will be 1000 by 800. So this is we know this one density, and again multiplied by 50. So we will get here 62.5 liter. So M by V, this will get 62.5 liter. Okay, so over. Now we know the molar volume also, we know the pressure also. So we can write here Z is equal to from here pressure is 162.5 is the molar volume, and R is we know that 0.0821 multiplied by temperature is 500 Kelvin. So we'll get after solving there will be 1 by 1.52. This is the answer. If the slope of jet compressive factor versus P curve is constant, so slope is constant, and slope they have given pi by 492.6 per atmospheric pressure at a particular temperature, and very high pressure and very high pressure, then under very high pressure, then calculate diameter of the molecules. So we have to calculate the diameter of the molecules. Slope is given, Avogadro number R, all these are given over here. So again, under very high pressure, what happens? So at very high pressure, there is a modification in the van der Waal equation at high pressure. So what is modification? So Z is written as 1 plus PB by RT. So this is pressures. Okay, so we can see here, this is the Z 1 plus RT. So this is the equation of line. So this is the Y, this is your C, and this is your M into X. So M is the slope, this is the slope. The slope is, so this is the Z versus P. So B by RT is the slope. So slope is what? B by RT. And B by RT is given here, pi by 492.6 atmosphere per atmosphere pressures. Okay. Again we know from B. So B is equal to 4 into a volume of one molecule into Avogadro number. It is also given. So we can compare with this thing. So from this we will get R, because we don't know R only. So comparing, this is equation 1, this is equation 2. So if you compare it, equating 1 and 2, equating 1 and 2. So this is 4 by pi by 492.6 is equal to 4 by 3 pi, and R we don't know, and 4 into Avogadro number. So 4 into Avogadro, so number is given. So again, if you solve it, so on solving, so we will get here 4 by 3, and pi is this pi is cancel, this pi is cancel, and Avogadro number, the value we know that. Okay, so B is given, this one 4 by pi RT is given here. So again we solve it, so we will get here 4 by 4 minus 6 and 4 by pi 3. Slope is given, B is given, sorry, one more thing, that B is given, B is B by RT, slope is equal to B RT, slope is equal to B RT. So here B equal to 4 into, slope is given, so B by RT. So B is this much, and R will be your 0.0821 and multiplied by temperature is 300. Okay, so this would be the complete value. So again what happens? So again solving here, so we'll get this side 4 by 3 pi RT, B by RT. So it is wrongly written. This is the B, and you have to divide by 0.0821 into 300. Okay, so on solving you will get here R cube is equal to, this pi cancels, so this will be your 3 into 0.0821 into 300 and divide by into 3, this value 492.6. so again 6 into 10 to the power 23, and this is 2 values there into 60. Okay, so on solving you will get here total value, something about, it will come about 246.3. okay, and divide by 492.6, so it will come something like this value. So and multiplied by 32 into 10 power 23, so it will come, so this I have calculated, so this will come like this, 32, so here divide by 2, 36, 32 is there. If you multiply this, and this will get this value. So on solving here, R is equal to 5.4 angstrom. So if you use calculator, it's angstrom. So diameter of molecule will be, number 2 into 5.4 angstrom. So this will be 10.8 angstrom. So this is the answer of the diameter of the molecule. calculate the pressure exerted by 5 mole of carbon dioxide in 1 liter vessel at 47 degrees centigrade using van der Waals equations, and report the pressure of the gas if it behaves ideally in nature. So here we have given two pressure. One is van der Waals equation, one is ideal gas pressure. So for van der Waals equation, so we can see here mole given, volume given, mole given, where pressure they are asking, and again one we can see more what mole, volume, temperature, A, B. So everything has been given over here. So van der Waals equation is P equal to N square A divided by V. This is equations, and again V minus NB equal to N RT. So we can see here pressure they are asking. So N, and we know that 5 mole. A is given. So we can see here B is also given. And we can see volume is also given, that is 1 liter. Temperature also given, that is 47. So 47 plus 273. So this will become 320 Kelvin. So 320 Kelvin. So this become, so also temperature given. So we can directly put this value. So van der Waals equation is how much? So this will be from here. This side pressure is equal to mole is 1 square. So right here mole is 5 whole square, and multiplied by A. So A is given here. So A is how much? 3.592. So 3.592 divided by volume. So volume is 1 whole square. This is completed. And now V is again volume 1, 5 into then B they have given. So B is 0.0427. This is the B. The B is given, and this is equal to nRT. So N is given 5, and R is given here 0.0821, and temperature is here 320. So everything is calculated. So pressure you will get here 77.218 atmospheric pressure. This I have calculated. So if you calculate, you will get this one. So this is the van der Waals pressure. Now for ideal gas pressure. So for ideal gas. So for ideal gas, PV equal to nRT. We know that PV equal to nRT. So we can see. So what is pressure? So pressure we don't know. Volume is 1 liter, and mole is 5 into 0.0821. Multiplied by 320. So here we can calculate. This is your 131.36 atmospheric pressure. So we can compare these two data: pressure of the ideal gas, pressure of the real gas. So pressure of real gas is lesser than the ideal gas. So why this is less? So we know very well, because there is intermolecular force of attraction take place between the molecules. So next equation, using van der Waals equations. So we can calculate the constant A when 2 moles of gas is confined to 4 liter flask exert a pressure of 11 atmosphere at temperature of this. So temperature given, volume given. So under previous questions, so A they are calculating, A they are asking. So mole given, mole is given value, volume is also given, B is also given, pressure is also given, temperature also given. And van der Waals equation we know very well, that is P plus N square A divided by V square multiplied by V in minus N into B equal to N RT. So this everything value you can see is given here except A. So just put value. So after putting 11 plus, this is your 2 square, 2 moles, 2 square plus A, volume they have given 4 square. So 4 square write it here, again 4 minus 2 into 0.05, this is also given, and 2 into 0.0821 multiplied by 300. If you solve here, so you will get here A value 6.46 atmosphere liter square per mole. So this is the direct value, it will come per mole. The direct value will come over here. A graph is plotted between pressure ppm mc motor volume of the gas, so along y axis, and p along x axis. So where Vm is the motor volume of a real gas. So find the intercept along y-axis. So graph is plotted this and along y-axis and this along x-axis. Molar volume given. So how to we have to find? Actually, we have to find the, if you get the intercept, we can say this answer. So molar volume is for 1 mole of gas. We know that for 1 mole of gas, van der Waals equation is P A square by Vm square into Vm minus B and equal to RT. So for 1 mole of gas, so if you multiply it, so PVm, so minus P into V, and here you multiply it, so this will be your A, so A square into Vm, you can say this is your Vm, and this is your A square into A square by Vm into B. This is also minus, this is equal to R into T. Okay, so multiplies R into T. Okay, so here I can, if you write separately this one, so PVm is equal to, so you put shift this side or equation this side, so RT plus P into B, and this will be your A square by Vm and minus A square by B into Vm. Now here to find the intercept, okay, so we have to find the intercept between two value. We have equations, we have the graph like this. This is the graph of PVM, okay, and this is the graph of Vm, goes like this. Okay, so we have to find intercept somewhere in between, intercept between PVM and Vm. Okay, this means, so if you take P equal to 0, mathematically if you take P equal to 0, so Vm will be infinity, large value. If you take large value, so then we can A square minus Vm, you can see here, put this value here, if P is equal to 0, infinity, put this value, so this value A square Vm, A square B by Vm is negligible. It has so small value that we can neglect it. So left, what left? So PVm is equal to RT plus PV. So for large value it is not applicable. Okay, so again if you put P equal to 0, if P equal to 0, so what will happen? So then PP 0, then RT equal to B. Okay, then here intercept will be RT. We can see here, this is the equation of a straight line, so PVM equal to P into V plus RT. So this is the Y and this is your M into X and plus C, and C is our intercept. So intercept is R into 3. So this is our answer.